Laura or Tia sold. There's three
Yeah.
variables.
Yeah. Right. So, yeah, the three things we don't know, right? We need to figure out what's Kelly's deal, what's Laura's deal, and what Tia sold, right? I hope that's a good way to say that. And so, something that we were looking at yesterday, that second question we looked at yesterday when I kind of said, hey, you guys look at that and see what we could find out. And I don't think anybody mentioned that they saw that there was two variables in there. Something that can be helpful to you beyond just looking at the numbers and stuff like that when you're reading the problem is that last part of the problem, right? When it says find both numbers, or on the third problem when it said, find the dimensions, like, that idea that it's plural, right, is letting us know that there's multiple things to find. Here on the first one, it just said find a number, so there's only one thing we were looking for there. So just paying a little bit more attention to the question side of things, like what am I being asked to do here, right? That question here is find, how much did each girl sell, right? Well, there's three girls, so that means I should have three answers, right? So reading into that there are three things we need to find here, not two, not one. So, okay. So with that, knowing that there's three things we need to find, that actually means we need to write three equations. When we had to going back and kind of just understanding what I need from the problem. If I had one number to find, that means I need one equation. And we have two numbers to find. We had two equations that we wrote. And then we had, two dimensions to find. We had to write two equations. So we need to write three equations. Okay. And another tip I gave you guys yesterday was that sometimes if you read a sentence, you can read that as, how do you write an equation for that sentence? So if we look at this first sentence here, well, the very first sentence is just information. It's not really going to help us write in math. Right? The second sentence, I guess. How do we turn that into an equation?
Wouldn't it be what Laura sold minus 15 equals what Kelly sold?
Say that again. Oh, you kind of broke up.
Would it be what Laura sold minus 15 equals what Kelly sold?
So like L minus 15 equals K?
Yeah.
Okay. Can I just turn that around, Peyton, so that I can put the K first? Is that okay?
Yeah.
No. I just prefer like when there's the single variable off on the left side, but the numbers don't care. But I think it's a little bit easier to read. Peyton, how do you know it's not this?
Because we have to have what Laura sold to get K.
We have to have what Laura sold to get K. Why do you say that? Well, we have to have why do we need to know what Laura sold in order to know what Kelly sold? Is that what you're trying to say?
I don't really know how to explain it, but I think we could actually use that.
The one I wrote?
Yeah.
Okay. We'll throw this out to more people. Can both of them work, or can only one of them work? Like, can we use either, or does it have to be just one of them? What you guys think? Can we use either equation, or do we have to pick one of them, or is one of them is right and one of them's wrong, or could they both work?
It would be K equals. You can't use both because well, it just wouldn't be right.
Okay, why is it the K equals then hope?
Because if you wanted to find, the bottom one would be finding how many boxes Laura sold, but how many boxes Laura sold would be K plus 15, I'm pretty sure.
You're saying it should look like that if I wanted to write it for Laura? Okay. What do you think, Stella? What do you think? Like, does it matter which equation we use, or could they both be right? Like, what's your thought there? So you think maybe both could work? Okay. What about you, Beckett? What do you think?
Can you repeat the question?
Can we use any of the equations, or or is one of them definitely wrong? Like, does it matter or does it not matter? That's kind of what I'm trying to get at. So, I mean, we're the ones writing the equations, so does it matter how we write it, right? Does it have to be a specific way, or we have some?
I'd assume we'd have to write it a specific way.
Okay, so is there one of them up there that you're thinking is wrong? Or two wrong? Or is there one that you think is right, and something like that? Like,
I think actually here maybe it shoot. I want to say like it doesn't matter, but like I feel like there's gonna be a scenario where it does matter.
yeah, so maybe on this problem it doesn't matter, but there could be other ones where it might.
Yeah, possibly, but like I want to say yeah, like it might not matter for like this situation, but like other situations it might.
Okay. All right, thanks, sure. Tatum, you're saying you don't think you can use the K minus 15. Why is that? Why do you think that? You hear me, Tatum? Okay. Says Kelly sold 15 boxes less than Laura, so you would have to add 15 to get how many Laura sold. Okay. So that's kind of what Hope was saying. I think, yeah, so, Peyton and Hope and Tatum, you guys all kind of said that you don't like the one that I wrote. You're not so happy about this one. So that's a good feeling. That was not a good equation that I wrote there. Those of you guys that are a little bit less sure about how to figure that out, I'm going to give you a couple ways to kind of think about it. Okay. What we're looking at here is writing a relationship equation, right? The number of boxes that Kelly sold is being related to the number of boxes that Laura sold. It's the same thing with the next one that says Tia sold twice as many boxes as Kelly. That's a relationship, right? Just like if I said, I'm 20 years older than you, that's a relationship between our ages. Or if, you have $50 more than me, that's a relationship between how much money we have. Okay. Those equations are really easy to mess up. Okay. Because am I supposed to add 20 to his number, or am I supposed to add 20 to my number, right? You know, am I supposed to subtract 15 from Kelly's boxes, or am I supposed to subtract 15 from Laura's boxes, right? How do I figure that out? Okay, it's a really simple equation, but it's also really, really easy to mess up. Okay, so I'd kind of give you guys two ways to think about it. You're trying to figure out which one it's supposed to be, and then you pick your method, like how you might want to do it. Okay, one, I think the easiest one I think is if you just say who's got more boxes, Laura or Kelly. You should be able to read that sentence and say who has more.
Laura.
Laura has more, right? And so we know that, right? We can make pretty easy sense of that Laura has more, right? Or Laura sold more. And so looking at the two equations that are written, right? So that means that K has to be smaller, right? We're saying that L has to be a bigger number, so K has to be smaller, right? So does a small equal big minus a number? Or does, the second equation, L, which being the bigger number, does big equal small minus a number? Which of those makes sense? Right? Doesn't make sense to take a small number and subtract something and to get a bigger number. That does not make sense. So we should not be thinking about that equation. Okay? So which means that one would be gone. Right? Which you guys had a feeling about. Right? So there should always be a way for you just to read and say which one's more, no matter what the relationship is. One of them's their numbers. One of the numbers is going to have to be bigger than the other numbers. So you should be able to read that and just make sense of it. And then go back and think about, should I be subtracting from a big number or should I be subtracting from a small number? Right? It doesn't make sense to subtract from a small number. Okay? So that's kind of just like a size comparison, right? To try to make sense, logic it out. The other one is you could just throw some numbers at it. Okay? For the most part, it doesn't matter what you pick. There can be some instances where you could screw it up, but for the most part, it doesn't matter. So let's just say Kelly sold 15 boxes. Or sorry, let's say Kelly told, I want to use a different number. Let's say Kelly sold 10 boxes. So how many boxes did Laura sell? If Kelly sold 10, how many did Laura sell? Reading that sentence, you should be able to tell me the answer. Kelly sold 10, how many did Laura sell? Yeah, 25. So when I go and plug the numbers in, so I'm saying, I'm just making up a number, right? I'm saying if K is 10, then L should be 25. So if I plug 10 in here and 25 in here, does it work? Is 25 minus 15 10? Yeah. Is 10 minus 15 25? No. So we can see that this equation does not make sense. Okay? So two different ways of eliminating an equation. If you're not sure, like, oh, should it be this way or should it be this way? You're not sure, there's two different ways of kind of thinking it through. Okay? Just purely big versus small, which I think is a little bit easier. Okay? Or throw a number at it. Okay? Make up a number. Okay, Kelly sold 2. Okay, then Laura must have sold 17. How do 2 and 17 work? Right? Is 17 equal to 2 minus 15? No. Right? Is 2 equal to 17 minus 15? Yeah. Okay, that one works. Okay? So just a couple things to think about, because these are so easy to mess up. Every year I've taught this. Okay? It's these relationship equations people really struggle with. It's not the other ones that you guys are working on, when it's telling you all this stuff to do, like 9 more than twice another. Right? People are actually better at those than these. Okay? So you got to slow down. You got to think, how do I make sure I'm actually writing the right equation? Because if I write the wrong equation, the problem's done. Okay? So we got to start, on that setup right. Okay? All right, so what about the second sentence, right? Or I guess third sentence here. Tia sold twice as many boxes as Kelly. How do we write that?
Would it be T equals 2K?
Okay. So what's the other option there, Peyton? So T equals 2K, what else could we have written that may or may not be wrong? Kind of thinking about what I was asking you earlier, like, could it be this instead?
I have no clue.
So I'm just saying, it could also be K equals 2T, right? We know we need to multiply by 2, right? Just
yeah.
which variable do we multiply, right? Is kind of my question. Okay. So then now that we know that it's one of those two, right? We're doubling one of them. How do we know which one's right? How do we make sense of this? Say, okay, this is the right one. The other one's junk.
Well, because if we would already have K and T is going to be more than K, and so they will not equal each other.
We already have K. What do you mean by that? Why are you saying that? We already have K. Are you talking about the equation I wrote?
Yeah.
Okay. All right. So that T was more, right? T should be bigger, right? Because T is sold more. So 2 times a big number
Won't equal.
should need a small number, right?
Yeah.
Small does not equal 2 times big, right? But a big could equal 2 times a small. Like that one makes sense. Right? So yeah, so that's letting us know that we shouldn't write it that way. Okay. So trying to make sense of it. Okay. Stop and think. You write your equation, put down your idea, but then you got to stop and think, does my equation actually make sense? Okay. Or what if T is sold? See, this is where it matters a little bit what you guess, like, or what you say. Hey, let's see what if T is sold 15 boxes. That doesn't work because twice, half of that is not a nice number. So you'd have to like pick an even number for Tia and say like, what if Tia sold 20 boxes? Okay, then Kelly must have sold 10. Like then you can make sense of it. So there are some limitations to just throwing any old number at it, and there's no way to kind of know that until you have a ton of practice with it. But that's why I don't like that method as much. But the big versus small pretty much always works. So reading one of them and saying, okay, this number should be bigger, Kelly's number should be bigger, or Tia's number should be bigger, and then using that comparison on the size makes more sense. Okay. All right. So we have one more equation to write. Remember, so we said we needed 3. They sold 83 boxes in total. I'm using up all my space here. How do we write that equation? They sold 83 boxes in total.
Would it just be K plus L plus T equals 83?
Yeah, K plus L plus T equals 83. All right. Total means adding things up. So add them up. All right. Okay. So we've got our 3 equations. We kind of highlight them. So we're using this one, and this one. Again, this is the main point I want you guys to be able to do. Okay. The rest of this is kind of a little bit of a cherry on top, so we can, if we understand how to solve this. Okay. I doubt you guys have ever solved a system of 3 equations before. Okay. Are there any questions on any of the setup stuff? And that's the main point of this.
No.
Okay. So remember what we did yesterday as far as the solving goes, right? We were able to find, we had this equation here talking about perimeter, and then we had a length equation that said the length is equal to this, okay? And so we took that expression and we shoved it in for L, just like we'd been doing with the kind of the function composition. The same thing here with this one. We had this equation relating X and Y, and then we had an equation that said that X equals all this Y stuff, and so we shoved that in there. The goal being to have one equation with one variable in it instead of 2 equations with 2 variables in them, right? There was only Y's left, or in this case, there was only W's left, and then we were able to solve for W. So we kind of need to think about that in the same way. We have some equations that just say, hey, T is equal to this, and K is equal to this. Okay? So we can use these to get rid of, like I can get rid of the T by replacing it with some K's, and I can get rid of the K's by replacing it with some L stuff. So I'm going to take this a little bit in 2 steps, so I don't overwhelm you. But what I want to do is I'm going to take this T equation. I'm going to take that expression that says, hey, T is equal to this. I'm going to drop that in here. So now I have K plus L plus, oops, I read plus twice, plus 2K equals 83. I got it right, Nate. Okay, so now I'm down to 2 variables, just K's and L's. So I'm getting better. I had 3, now I have 2. That's better. Okay. Still have this other equation though, up here. And it tells me what K is equal to. So I'm going to replace all the K's in that second equation with this. So that's going to go in here, and it's going to go in there. Again, this part's just gravy, okay? This is freaking out. Don't worry too much, okay? It's not what your homework's going to be like or anything like that. So that first K is going to become an L minus 15. And then I have the plus L. And then I have the plus, and then I have 2 times L minus 15. So you see how we were able to get it down from 3 variables to 2 variables. Now there's only 1 variable. That means now we can solve it. This is just the substitution method, but with 3 equations rather than 2. Anything really weirding you out there?
Since I saw that there's a K in both the equation to find L and T, I plugged in, well, L and T.
You plugged in L and T.
Yeah, to get
Like you brought.
K plus 15.
Did you bring this like over here? Like you took this to here or something?
No.
Okay. Can you tell me where you're at then? Sorry, I think yours.
Yeah, I plugged in L and T to get K plus 15 plus 2K.
Oh, okay. So you took. Okay, because you used this one, right? And you plugged that into here.
Yeah.
Okay, yeah, that works. Yep, definitely. Yeah, more than one way to skin this cat. So yeah. So yeah, Hope noticed that she could change the L's into K plus 15s. So she did that here. She took the T, which she knew was 2K, and she put that there. So she had K plus 15 plus 2K. Here. So yeah, that works. That works just fine. So at that point, right, you have a bunch of K's, right, and some 15s or something like that. I've got a bunch of L's and some 15s, so I need to combine like terms. So we think about what's going on here. I have 1 L, I have 2 L's, and then I have 3 4 L's here. Okay. 1, 2, 3, 4. 4 L's. Okay, so 4L. And then I've got some constants. So I have negative 15. And then this would be negative 30, right? So negative 15 and negative 30 would give me negative 45. So I'm just doing some combined like terms. I could obviously write this out in more steps. I'm just trying to, I'm out of space, so I'm not doing that. Okay, but that's what I'm doing. Just combining like terms, doing my distribution. So pretty normal steps that you guys should be used to. Okay, so I'm just kind of rushing past that. Okay, and then from here, I'm just going to solve this by like normal. So I'm going to add 43 to both sides. So I get 4L, 43 plus 45 plus 83. Let me do it right this time. I screwed this up first hour. It'll be 128. And then when you divide by 4, you find out that L is equal to 32. And this is 32 boxes, right? That's what the question was about. So Laura sold 32 boxes. So we still need to figure out what Kelly and Tia did.
What? Where did you get negative 45 from?
Yeah. So I had the 15 here, right? And then I had 2 times 15, which is 30. So 15 and 30 give me 45.
Okay, thank you.
Yeah, I was skipping some steps there. So now that we know what Laura did, what can we figure out next?
What Kelly did,
Okay, why is that big?
because you can just put L in,
Okay.
and it'd be 32 minus 15, and that's what Kelly sold.
So what's 32 minus 15?
17.
17. So Kelly sold 17. So 17 boxes. And then what about Tia?
Tia sold 2 times that, so that's 34.
Yeah, Tia sold 2 times that, 2 times K. Oops. 2 times k is what Tia did. Yeah, so 34 is 2 times 17 round. So T equals, I want to do a different color. T equals, yeah, so we're just plugging those back into those equations we wrote earlier. Last thing you really should do would be to add those together, make sure they actually do equal 83, but let's get past that right now since we've straight up out of room. So but just you can do that mentally, like do they actually add up to 83? Just check them real quick. There's a lot going on there again. Okay, as far as the solving goes, again, we will probably go over this whole method again at some point later. It's just what I really want you guys to be focusing on is, can you write the equations, the stuff here in the purple, right? Reading those sentences and saying, okay, here's how I need to write this. Here's how I need to write this. Here's what totaling means. You know, how do we figure out which one's right when we have a couple equations? Or when I look at my equation, kind of judging it, does that actually make sense? Can I take 2 times a small number and get a big number? Or am I trying to take 2 times a bigger number and getting a small number? Like, I want you guys to stop and think, because if you write this equation wrong, then none of this is going to matter. You can do all this perfectly and it's not going to matter. Anything there you guys want to talk about? That was a big problem. Okay. This next one's kind of fun. So the sum of 4 consecutive integers is 222. Okay, and we want to find those integers. We just kind of think about like what the heck are they talking about here when they say 4 consecutive integers. So that would mean something like 2, 3. Our Lord. Handwriting struggles. 3, 4, 5. Those are 4 consecutive integers. Okay, or 11, 12, 13, 14. Okay, so those are 4 consecutive integers. All right, so that's what our goal is, right? We're going to find those 4 numbers that add up to 222. Okay. So thinking along that line, right? We have find 4 things. Should we have 4 variables here, right? Just like on the last one, we had Kelly and Tia and Laura. They all had their own variable, right? So should I have 4 things like X and Y and Z and then, I don't know, W or whatever? Well, if I want to have 4 variables, I have to have 4 equations, right? We had, when we talked about, this first problem, second problem, right? We had an equation that had an X and a Y in it, and then we had another equation that had an X and a Y in it. We had 2 equations with 2 variables, and then we were able to find a way to get them to be 1 equation with 1 variable, right? And same thing here with the, we had this perimeter equation here with an L and a W in it, and then we had this length equation here with an L and a W in it, and then we were able to find a way to get them down to 1 equation with 1 variable. We had 1, 2, 3 equations, and then we were able to work it down to 1 equation with 1 variable. Well, I'd have to write 4 equations if I want to have 4 variables, and we don't have a lot of information here, right? How are we going to write 4 equations out of that one sentence? Okay, not really going to happen. So we need to be thinking about something else, right? So if we only have 1 sentence, there's a pretty good chance we're only going to be able to write 1 equation, which means I can only have 1 variable. Okay, so let's use X or whatever you want. Okay, it's talking about summing, right? We know that means add. So we're going to be adding these 4 numbers. We're supposed to get 222 when we're done. Well, how is 3 related to 2? How is 12 related to 11? What's the relationship there? How is 3 related to 2? How is 12 related to 11?
Adding.
We're adding 1, right? Tatum, right, Peyton. Okay. So to get that number, we take whatever the first number was and we add 1 to it. Well, what was our first number? It was X. So the second number would have to be X plus 1. Okay. Well, how is 4 related to 2? How is 13 related to 11? How is 4 related to 2? How is 13 related to 11? How is the third number in our
Plus
list?
2.
Plus 2, right? So we take that first number and we add it 2 to it. Yeah. In the same way, how's that last number related to the first number? Because the first number is the one that we named as x. So we're always going back to the first number. I'm not trying to relate 5 to 4 or 14 to 13. Okay? They're all related to the first number because that's the one we named. And so then we'd have to say, well, that's plus 3. Okay? That last number is 3 bigger than the first number. Yep. Both times, right? The third number is 2 bigger than the first number. Yep. And the second number is 1 bigger than the first number. Yep. And that's what it means to be consecutive. They grow by 1 each time. Okay? And then that one's 1 more than that. And that one's 1 more than that, right? Well, how many x's do we have?
4.
4. What about our constants? What are our constants add up to?
6.
6. So we have 4 plus 6 equals 222. Very darn easy equation to solve now, right? So if we subtract 6 over, we get 216. If we divide by 4, we find out that x would be, what, 54. So we'd want to find all 4 numbers. So 54 was our first number. Then that'd be 55, and then 56, and then 57. Yeah. And we could check to see if it works, right? 50 plus 50 plus 50 plus 50 is 200. 4 plus 5 is 9, plus 6 is 15. 15 plus 7 is 22. So 200 and then 22. Yeah, so it does add up. So different way of thinking because we have so little information, right? They're only telling us that they're consecutive. They're not giving us all this other stuff to write more and more equations, right? So we have to have just one variable. Okay. Anything about 5 there you guys want to talk about?
Wait, so how'd you get like the consecutive like 54, 55, 56?
That's just part of the definition, Connor, is that we're looking for consecutive numbers, right? So consecutive numbers are just like 2, 3, 4, 5. So as soon as I knew the first number, right, I said my first number was called x, right? And so as soon as I knew the first number, then I knew the next number would have to be 55. The next number would then have to be 56. The next number would have to be 57.
Okay.
Right? Because that's what consecutive means. One right after each other.
Yep.
No, okay, this is a little different. I'm just trying to get you guys to think. The homework's easier than this. The homework's pretty similar to last night. Just trying to stretch your brains a little bit. We'll often do things like that are pretty difficult in class together, and then we'll so I can like push you guys, and then when you're doing stuff on your own, it's I bring it back in, make it a little easier for you. Then we have this opportunity to talk and discuss things, want to do things that are harder. So, last one's pretty similar to the one we just did. Okay, we see that we're consecutive again. Only thing different here, right? So we're talking about consecutive odd integers. Okay. And we got 3 of them they want to talk about. Okay. Still summing. So what are consecutive odd integers, right? So like an example would be like 1, 3, 5, right? Or 17, 19, 21. Okay. So if we think about how we started the last one, right? It was we want to sum, so we need to add some stuff up. We start off with some number, right? And then we're going to add, in this case, 2 other numbers to it, and we're supposed to get 93 as our answer. All right? We just need to figure out how to write these other 2 numbers in relation to that first number. So how does our second number relate to our first number?
Would it be x plus 2?
X plus 2.
X
Okay.
plus.
And then how does our third number relate to our first number? I think I heard you. I couldn't quite hear you, Peyton.
X plus 4.
X plus 4, right? Okay, so since we're having to jump numbers, right, since we're just doing the odds, we have to add 2, and then we have to add 4 to go consecutive, right? And it'd be the same thing with evens, right? If I was going to write a list of consecutive evens, it would be one number, X, and then the next number would be 2 away, and then the next number would be 4 away, right? So it doesn't matter if it's even or odd how you write it. It's just that idea that you're skipping, right? We're not doing every number, right? We're not increasing by 1 each time. We're increasing by 2 each time. Right? No matter if it's even or odd, you're still going up by 2 each time, which some people get tricked up by because they think, 2s are evens, right? But the distance between every odd number is also 2. Or distance between consecutive odd numbers is 2. Okay? And once you're here, right, the equation is really easy to solve. It's just that idea of like, how do we deal with consecutive odd integers? Right? How do we write them out? And again, in relationship to one number. So what we would call this is that this is in terms of X. We wrote this number in terms of that number. So that way we didn't have to create a new variable. Same thing here. We wrote this number in terms of the first number, so we didn't have to create a new variable. We got 3 X's and we got 6. Subtract 6. What's that, 87? What's that? What's that, 29? So what are our 3 numbers?
Would it be 29, 31, and 32?
Okay. So 20 plus 30 is 50, plus 30 more is 80. 9 plus 1 is 10, plus 3 is 13. So 80 plus 13 is 93. So we can see that does add up.